In this demo, I'll be showing you how to create trait objects. Trait objects allow you to store multiple different types of data in a single collection. What I'll be making is a program that allows you to apply different discounts to sale prices. So the first thing we'll need to do is create a trait. I'm going to name it sale, and it's going to return an amount. And the amount will be implemented differently based on the type of sale. Next, I need to create the sale prices. So we'll have a full sale. We'll have a $1 off coupon. And we'll also have a 10% off promotion. The next thing we'll need to do is implement our sale trait for each of these structures. So we'll implement sale for the full sale first. The full sale, we're just going to return the amount as is. We are working with a tuple struct here. So we have a tuple, and this can be accessed by .0. So we're just going to access whatever value is right there. Next, we'll implement the $1 off coupon. And this is just going to be the value minus 1.0. It's $1 off. Next, we'll implement the 10% off promo. And this one will just be self times 0.9. And that will give us 10% off of the sale price. We're also going to need a function to calculate the total amount of revenue retrieved from these sales. So I'll just call it calculate revenue. That's going to accept some sales. And we're just going to borrow a vector. And that's going to have a box of dyne or dynamic sale. And we'll return in F64. When working with trait objects, we use the din keyword. That's short for dynamic. We have to put it in a box because when we're working with a sale, the sale is just a trait. It's not an actual type. Traits don't have sizes, so they can't properly be calculated in order to lay out memory correctly. However, when we place it within a box, we know that a box is a usize because it's a pointer. So we're able to store any amount of pointers within our vector because they're all the same size. For our calculate revenue function, we're just going to take the sales, turn it into an iterator, map the sales into we'll get the amount by mapping the sale, and calling the amount function, which is implemented on the sale trait, and then just sum it, and that'll give us the total sales. The next thing we'll need to do is utilize this program by creating a price. So we'll set the initial price to $20. We'll then make a few sales. So here we've set the price to $20. We have a regular sale, which is the full sale price. We have a coupon, which is a $1 off coupon. And we have a promo, which is a 10% off promo. If we look at these structures again, we'll see that the full sale just returns the amount. So whatever the sale price is, that's what they're going to pay. The $1 off coupon will take $1 off the price. And the 10% off promo will return 90% of the price, which will be 10% off. Remember, our sale trait just has an amount, which returns the amount after applying a sale. The last thing we'll need to do is put all these sales into a vector. Now that we've boxed up our structures and we've placed them into a vector, let's run a cargo check and see what happens. We're getting an error here that indicates we have mismatched types. If we look at our vector, we see we have a regular sale, a coupon, and a promo, and we know they're all boxed, but we're still getting an error. So what's the deal? By default, Rust tries to do everything statically and calculate everything up front. So even though we're boxing everything, it still wants all the boxes to be the same type. Since the regular was the first one in the vector, it expects all of the sales to be full sales instead of any coupon sales. So the box at this point is irrelevant. When you're working with trait objects, we have to remember to always use the din keyword somewhere, so Rust knows to treat this dynamically instead of statically. Let's hop back to the code and make the necessary changes. So all we'll need to do is annotate this sales vector by giving it a vec box din sale. We don't need to make any changes with the boxes. We don't need to make any changes with the vector. We're simply adding a type in annotation. So we're telling Rust that we have a vector that contains boxes, and within those boxes, it's a din sale. The din sale is important because by default, when you make a vector, it will try to take the first element and use that as the type. Since the first element is a box of full sale price, that'll be the default. However, when we use din sale down here, we're telling Rust that we're going by the trait instead of the actual type itself. If we run a cargo check again, we should no longer get any errors. So everything checks out. The last thing we need to do is actually calculate the revenue and get a result. We'll use our calculate revenue function that we made earlier, and we'll just borrow the sales, and then we'll print out the total revenue. Let's go ahead and run this and see how much money we made. So the total revenue of the sales was $57. Using trait objects in this way allowed us to combine multiple different structures into a single vector and then perform an action on all of the different structures to get a result that we wanted. Trait objects are a great tool when you need to perform actions like this. If we have another promo or a different coupon, we can easily just create a new structure, and then it'll automatically work with our program because we can just add it to the vector. And since we implement the sale trait, everything will work out fine, and then we can have a completely new sale without changing any code except adding a new structure. This concludes the demo on implementing trait objects. I'll see you in the next presentation.